In this video, we will explain how to compute the determinant of a 2 by 2 matrix and its geometric representation. We have a 2 by 2 matrix, let's say A equal to A, B, C, D. Then the determinant of A, which is denoted by sometimes by capital D, E, T, or by this. Determinant of A is just the product of A with D minus B with C. And here are some examples. We have 1, 2, 4, negative 2, right? Then in this case, the determinant, if this is A, then the determinant of A would be 1 times negative 2 minus 4 times 2, and this is negative 2 minus 8, and this is negative 10. Let's see what this number means. If we consider the two rows of the matrix, and let's draw the two rows, 1, 4, let's say the row 1, 4, 1, 1, 2, 3, 4, this vector, the vector 1, 4, and the vector 2, negative 2, 2, negative 2. Then we have these two vectors. The first vector is here, and the second vector is here. The number 10 means the number 10 is the area of the parallelogram that you get by considering the points, the vector, the other vector, and the sum of the two vectors, which is here. Then this area is 10. Area is 10. And the reason of the negative is because if you consider like this is x1 and this is x2, then the direction from x1 to x2 is counterclockwise. But here, when you consider these vectors 1, 4 and 2, negative 2, if you consider this to be the first vector and this the second, you see that to go from the first vector to the second, you go clockwise. Then here you have a negative 10. But then you may wonder, do you have to remember that I have to consider the rows and not the columns? In this case, you don't have to worry about that because the interpretation works if you take the columns or if you take the rows. For example, let's take the first vector to be the vector 1, 2. Where is the vector 1, 2? Here is 1, 2. This is the vector 1, 2. Right? 1 and 2. This is the vector 1. And the vector 4, negative 2. Now I'm taking the columns. 4, negative 2. 4, negative 1, negative 2. This is the second vector. And in this case, the area of this parallelogram, something like this, right? Do 1 and 2. This area of this parallelogram is going to be 10. And the reason of the negative is because if you go from 1, 2 to 4, negative 2, then you are going to go clockwise. And then anytime you go from 1 to 2 going clockwise, the determinant is going to be negative. Okay, then this is the first example. We have another interpretation for this determinant, and it has to do with the transformation T of A. Let's remember that the transformation T of A is a transformation, in this case, from R2 to R2, and it takes a vector V into the vector A times V. And then, for example, it takes the vector 2, 1. It takes this vector into the vector 1, 4, 2, negative 2 times 2, 1, which is the vector 2 plus 4 is 6, and 4 minus 2 is 2. then it takes this vector into this vector. We can see that it takes the vector negative 1, 2 into the vector 1, 4, 2, negative 2 times negative 1, 2. And this is the vector negative 1 plus 8 is 7. And here we have negative 2 minus 4 is negative 6. Then, and also easy to check, it takes the vector 0, 0 into the vector 1, 4, 2, negative 2 times 0, 0, which is just 0, 0. Then, if we pick any triangle, then if we pick these 3 points in the domain, this is the domain, and we do the triangle with these 3 points, 0, 0, negative 1, 2. This is negative 1, 2. And here we have 2, 1. 2, 1. And we take the triangle made by these 3 points. Then this triangle will go to the point 0, 0. Right? 7, negative 6, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 7, negative 6, and here the other one is 6, 1, 2, 3, 4, 5, 6, and 2, 6, 2. Then when you think about this triangle, then the determinant was equal to 10. That means that if you compare the area of this triangle with the area of this triangle, this area is going to be 10 times bigger than this area. Let's do another example like this. If our matrix A is 2, 3, 4, 6, then in this case the determinant of A is 2 times 6 is 12 minus 3 times 4 is 12 is equal to 0. And that means that if you consider these 2 vectors, 2 and 4, 2 and 4, which is this vector, and then you consider the vector 3 and 6, 3, 4, 3 and 6, that means that the parallelogram formed by these 2 vectors has area 0, and this is true because the 2 vectors are parallel. Notice that the interpretation works if you consider the columns 2 and 4 and 3 and 6. You can also consider the rows 2, 3 is here, and 4, 6, 4, 1, 2, 3, 4, 5, 6 is here. Then in this case we are thinking about these 2 vectors which are parallel, then they have area 0. It is not difficult to check that the determinant of any matrix is going to be 0 if and only if the determinant of A is 0, if and only if A is a singular matrix. We can also see the interpretation of T of A. If we have T of A goes from R2 to R2, and for example, if we take 2 vectors, let's suppose that we take the vector 1, 1 and the vector 2, negative 1, 2, negative 1. Then in this case, if you consider this triangle, let's see where this triangle goes. 1, 1. 1, 1 will go to 2, 4, 3, 6 times 1, 1, which is 5, 10. And let's 5, 10. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 times is here. And the other vector 2, negative 1, we have 2, 3, 4, 6. 8 times 2, negative 1. We'll go to 4 minus 3 is 1. And 2 times 4 is 8. Minus 6 is 2. You will go to the vector 1, 2. And then, in this case, this triangle will go just to this segment. And what is the area of this segment? It's 0. That means that the area of this triangle multiplied by 0 times the area of this triangle is equal to 0 times the area of this triangle, which is 0.